What's up, barbarians? Um, I like that one. That's a good intro. That one smacks. That one hits a little different. You know what I mean? What a good one. The person who suggested that, genius. You should write YouTube scripts. Um, I'm serious. You have a future in writing, and not like English writing, not like lame writing where you write like the author clearly intended to illustrate how society isn't fair, especially if you don't make a lot of money. No, no, no. I'm talking like intros, outros, funny jokes for YouTube videos, stuff like that. Like meaningful writing that people care about. You feel me? Um anyway, we're going to talk about math operations on polynomials today. And you're going to like this lesson because this lesson is hecka review for you guys. 90% review. Sorry, I had to move a little thing. I'm pretty sure you guys already know everything in this video. This video is just like me formally telling it to you so that you guys can't be like, well, technically, Mr. Barton, you didn't do your job and teach me how to subtract good. So this is just the formalization. We're going to talk about how to multiply. Ah, come on, I knew it. This never works. This never works. But I swear, these pens are dog doo-doo. Speaking of dog doo, if you hear my dogs putzing around, it's because they just got locked in. Sorry about that. So, all right, we're going to learn to multiply, add, and subtract polynomials. And you're going to say, well, Mr. Barton, what about division? Well, you forgot a math operation, Mr. Barton. Are you complaining? Are you telling me you want to do more work, homeboy? I didn't think so. The real reason we're not putting and dividing is because dividing is way harder than the other three, and it's going to take a whole lesson just by itself. That is the only new math operation you're going to learn in Algebra 2 as far as what we do with polynomials goes. So think of today as like, let's review all the stuff you already know about doing math of polynomials. And then in the next video, probably today even, I don't know what your schedule is because maybe you're like in the year 2070 and you're like uncovering this in some kind of crazy buried archive and you're like, oh, dude, what if Martians dig up my laptop, decode all the information on it in like 1,000 years, pull it out, and they're like, what do you guys think a gamer is? You feel me? That'd be so tight. Sometimes I think about stuff like that, and then I'm like, I should put really funny stuff on my laptop so aliens find it. Oh, what a funny joke. Anyway, let's go learn some math. All right. So we're going to talk about the easy stuff first. Adding and subtracting polynomials. There's a lot of words here. Let me point out some of the important ones. You're going to add or subtract terms with the exact, that doesn't mean like pretty close. You know what I mean? This means exactly the same variable and exponent. This is basically saying, like doesn't start with an S. Like terms only. Okay. You want to think of adding and subtracting polynomials as just combining like terms. That's what we're doing. For your coefficients, you're going to either add them or subtract them. You're going to do just whatever the sign says. Don't think too hard about it. We're going to keep the variable and the exponent. The variables and the exponents should not change for adding and subtracting only. When subtracting, we're going to change subtraction into addition by, it says flip the signs here, but what we're going to do is we're going to distribute the negative. And if you do this, what is that? That goes over there, I think. If you do this, you can't fail. It's impossible. Unless you really put your mind to it, but c'est la vie. All right. So, important thing to note, your degree can't change, but that's basically saying the same thing as keep your variables and exponents. Make sure you write stuff in standard form, and we'll talk about that. All right, let's just look at some problems here. So I don't have way too many examples for you like normal because this is a review. So here we are subtracting because there's a subtraction sign in between the two parentheses. So to subtract, the first step, step uno, is distribute the negative. You have to. So we're going to distribute the negative through the whole second one. This stuff is going to stay the same. So we're still going to have 5x cubed plus 2x squared minus x plus 7. Here, the negative turns this negative. So minus 3x squared plus 4x minus 7. Then step number dos is combine like terms. So let's do this in red just so I can stay organized. All right, I've got 5x cubed. Do I have any other x cubes? Nope. Bring that down. 5x cubed. I cross it out so I make sure I don't accidentally use it again. I've got 2x squared. Oh, I also have a minus 3x squared. So 2 minus 3 is negative 1. Keep the variable and the exponent the same, x squared. Now I have to cross them out so I don't accidentally use them again. Negative x plus 4x. Negative x is the same thing as negative 1x. So negative 1 plus 4 is positive 3. Bring down your x, cross them out. And then 7 minus 7 is 0. You could put plus 0, but that looks kind of sloppy and lame. So we just omit it or drop it. It goes away. And then this is your answer. You're done. You did it. Congratulations. You're almost done. All right. You're going to see stuff like this as well. If you have coefficients here outside the parentheses, step 1, or maybe step 0, right? If we take our same steps from up here, we take these, we just need to add a step 0, distribute. Or maybe that is step 1, right? Distribute, instead of the negative, we should say the coefficients, and the negative is just part of the coefficient, okay, no? So distribute the 10. 10 times 4 is 40, x squared. 10 times 3 is 30. Negative 8x times 3x. Negative 8 times 3 is negative 24. X times x, remember add the exponents, the invisible ones, is x squared. Negative 8 times negative 1 is positive 8. Bring your x down. Now, okay, so we did those steps, both of them. Now we just combine like terms. So let me switch colors one more time. What color do you guys like? Purple this time? So 40x squared. Oh, I do have another x squared right there. So 40 minus 24 is 16 x squared. Then we have 8x. We don't have any other x's anywhere. We had x squareds, but we already took care of those. No other x's though. So this just comes down. Plus 8x. Cross that out. Then plus 30 comes down because there's no other like terms. And then this is your answer, and you're done. Easy peasy, lemon squeezy. All right, cool. Let's do the next one. All right. Multiplying polynomials. Basically, all you're doing is either distributing or foiling. These are the same thing, right? Math teachers we're trying to, right? It's old habits die hard. It's like smoking and getting back with your ex. You know what I mean? It's like, I really don't want to do this, but it's a hard habit to break, you know? It's just, sometimes you gotta. So FOIL means distribute, but it's like an acronym that helped kids do like 3x plus 2 and 2x minus 7, right? It's first, outside, inside, last. It's an acronym that's telling you how to distribute. But anyway, I digress. You probably don't care. So we're going to distribute. You multiply the coefficients, you add the exponents. That's all you got to know. These words are probably extra. If you really want to, you can pause the video and read them. So let's look at some examples. So for our examples, sorry, I just had to make sure my pen still worked. We're going to just distribute here, and I'll show you these weird exponent things, and then we'll do like the long problem. So here we're going to distribute 2xy to all three of these terms in here. Remember, we are multiplying the coefficients, adding the exponents of matching variables. So we're going to add the exponents of the x's together. We'll add the exponents of the y's together and so on. But the letters have to match. So 2 times 5 is 10. X to the first times x squared. 1 plus 2 is 3. Y to the first times y to the first. 1 plus 1 is 2. Y squared. Next term. 2 times negative 4 is negative 8. X times x is x squared. And then this y doesn't have another y to add to, so we just bring the y down. 2 times negative 1 is negative 2. There's no x's or y's for these x and y to multiply to, so we just bring them down. X, y. And then this is the answer. As far as standard form goes, what you want to be looking for is you want the terms in order from biggest exponent to smallest exponent. And usually you do that based on one variable. So pick a variable and do it based on that. Usually they'll pick x, or if it's like ABC, they'll do it with A. It's whatever the first variable in the alphabet comes with, or sorry, whichever letter in the alphabet comes first. But it can change. Like after you get a whole bunch of variables, people get a little wishy-washy with it. But in general, biggest exponents first and then descending order. Okay. 7x minus 2. This is multiplying, believe it or not. And you're like, I bet some of you on the first screen when I say we're going to learn multiplying, adding, and subtracting, not division because it's too hard. You went, wait, the other math operation is squaring. Like, isn't squaring a different math operation? You forgot that math operation, Mr. Barton. Technically, you guys get all snotty about it. No, you don't be a snotty brat. Squaring just means this thing times, that's multiplying, itself. So this is still multiplying. So we're going to just take this thing, write it twice, and then we're going to distribute. So 7x times 7x is 49x squared. 7x times negative 2 is negative 14x. Negative 2 times 7x is another negative 14x. And then negative 2 times negative 2 is positive 4. Oh, no. Okay, sorry. There's a dog emergency going on in my house. 1 second. Sorry about that. My dogs are being crazy. So we need to combine our like terms. So we're going to take these two negative 14x's. Negative 14 minus 14 is negative 28x. Bring down your plus 4. Bring down your 49x squared. Ta-da, you're done. And you're like, Barton, this is easy, easy, lemon easy. Because I already done this. Because you do these problems all the time. One more big kid problem. This is why we don't use FOIL. Because if you do first, outside, inside, last, do you see how you skip that term? That's why math teachers are trying to, move away from that terrible acronym. But it works over here. So we're going to take the 2x and we're going to distribute it to every single term. So 3 multiplying. So 2 times 4 is 8. X times x squared is x to the third because we're adding exponents. 2 times negative 3 is negative 6. X times x is x squared. 2 times negative 1 is negative 2. Bring down the x. Then I'll switch colors. And this is just to help me keep it straight. I'm kind of dumb, so I've got to like color code everything. Otherwise, I can't do it. So now we'll do the -5 times everything. So we're going to do -5 times 4 is -20. Bring down the x squared. -5 times -3 is +15. Bring down the x. -5 times 1 is +5. Now we combine like terms. So we don't have any other x cubes, so we'll just bring that one down. 8x cubed. Cross it out so we don't use it again. -6x squared minus 20x squared is -26x squared. -2x plus 15x is 13x. And then bring down the +5 because there's nothing for it to combine. There you go. You're done. You did it. Ta-da! You're masters of multiplication. You guys, doing funny voices is so fun. Have you ever tried it? You should. Walk into the other room right now. Like, pause the video, get up, go find someone else in your house, and just do a funny voice at them. Be like, go up to your mom and pretend to be like one of those dejected Elizabethan children in like those old movies. Be like, Mother, please, we need sustenance. Could you make me some porridge? And see what she does. If your mom hits you with a sandal, I'm sorry. All right. Let's just see where we're going. Okay. So we're going to do one more really big kid multiplication, hecka distributing one. We will use 3 different colors here, and then we'll do some word problems so that you guys don't get scared when you see word problems on your homework. So we're going to start with the 2x squared. We're going to distribute that to everything. So 2 times 3 is 6. X squared times x to the third is x to the fifth. 2 times 10 is 20. X squared times x squared is x to the fourth. 2 times -2 is -4. X squared times x is x to the third. We're done with that. Change colors. Now we're going to do -6 to everything. -6x. So -6 times 3 is -18. X times x to the third is x to the fourth. -6 times 10 is -60. X times x squared is x to the third. -6 times -2 is 12. X times x is x squared. Now we're going to switch to, let's do green. 9 to everything. So 9 times 3 is 27. Bring down your x cubed. 9 times 10 is 90. Bring down your x squared. And then 9 times -2 is -18. Bring down your x. Now we pick our next favorite color, purple. And we combine like terms. So we have 6x to the fifth. That's the only fifth power that we see. So we just bring that down. 6x to the fifth. Cross it out. Then we have 20x to the fourth. Oh, I have a -18x to the fourth. Any x to the fourth over here? Nope. So 20 minus 18 is 2. Keep the variable the same because we're adding and subtracting now. Cross them out. -4x cubed minus 60x cubed plus 27x cubed. I might have to do some not mental math here. -4 minus 60 is -64 plus 27. What is that? Let's see. Add 7. That would turn this to 57 plus 20 more. That would be -37. -37 x cubed. Cross those all out. Then we have 12x squared plus 90x squared. So 12 plus 90 is 102 x squared. Cross them out. And then minus 18x. And here is your answer. That one was tight, huh? All right. Now we'll do some word problems just to make sure you really have the hang of this. And then homework. All right. So this says write an expression. That means expressions are equations without an equal sign. So they're saying like this thing. That's an expression because there's no equal sign here. It's just a list of terms being added and subtracted. So we're going to write a polynomial for the area of the rectangle below. The first thing we need to remember is what's the area of a rectangle? It's base times height. So the base here is this whole length together. So our base from here to here is x plus 7. And we don't know what x is. Maybe the architect is like, well, we want it to be kind of this ratio, but we don't know how big yet, right? They haven't decided how much money they want to spend. So we'll leave it as a variable, right? So that's from here to here, and then plus 18 feet. We want to know the whole thing, though. So how would I get the whole thing? Well, if this was 7 and this was 18, you just add them together and get 25, right? So we need to add these together first. So x plus 7 plus 18, this is x plus 25. So that's our base. So let's write that down. X plus 25. Now we need to multiply that to our height. Well, from here, hold on, let's change color a little bit. From here to here is x, and from here to here is 5. So the whole thing is x plus that fifth, those 5, so x plus 5. Okay. Now the area is these two binomials multiplied together. So we're going to distribute. So x times x is x squared. X times 5 is 5x. 25 times x is 25x. And 25 times 5 is 125. Combine like terms. X squared plus 30x plus 125. And this is the expression for the area of that whole rectangle. You're probably going to have one or two of these on your homework. All right. Let's just talk about some names really quick. This maybe should have been a little earlier, but c'est la vie. We're 22 minutes in the video and we're not doing it again. Heck it, I'll do it live. So a term is just any one piece of a polynomial. So for example, x squared is a term. 30x is a term. 125 is a term. 6x to the fifth is a term. Negative 37x to the third is a term. Any individual piece that's separated by a plus or minus, that's a term. Okay, so it's any combination of a coefficient, a variable, and they could have exponents. Okay. A polynomial is an expression, so an equation with no equal sign, that contains one or more terms. These are terms. All three of them together is a polynomial. Okay. Standard form is just putting those terms in order in your polynomial from the highest exponent to the lowest exponent. So big numbers first, then small numbers later. Descending order. Lastly, the degree of a polynomial is just the highest exponent of that polynomial. So here, the degree of this whole polynomial would be 2 because the biggest exponent is a 2. The degree of this polynomial is a 5 because the biggest exponent is a 5. Okay. And then these are just a bunch of examples because it's like you didn't see a whole bunch of examples. You don't need to write this down. The important thing you might want to write down maybe is like the names. So a number by itself is just a constant. A single term with an x in it is a monomial. Mono is the Greek or Latin prefix, I don't know which, for one. I can't give you any good examples. Mononucleosis is the only one I can think of. And I'm not even sure why that one's called that. That's the kissing disease. Don't kiss people. It can make you sick, apparently. Bi is the prefix that means 2. Like bicycle has 2 wheels. Bisexual, you're attracted to 2 different genders. Binomial has 2 terms. Tri is 3. 1, 2, 3. And then poly is the generic prefix for many. So we use poly for anything 4 and up. You could probably look up what is 4, what is 5, what is 6, and get those names. But in this class, we're lazy, and we're just going to say poly for anything more than 3. Poly technically applies to trinomials and binomials as well. Not technically, probably not a monomial, because poly means many and mono means one, but in general, a polynomial is just a list of things being added and subtracted together. All right, so now that we're done with vocabulary, we are done. You can go complain to me in the WebEx. Mr. Barton, your videos are too long and your jokes aren't funny and your impressions of us are degrading. Sorry, don't sound like that. I don't know what to tell you. Until next time, have a great day, you guys.